Hello everyone, welcome to my channel. In this video, I discuss a problem on mesh analysis. Using mesh analysis, determine the voltage Vs, which gives a voltage of 50 volts across the 10 ohm resistor as shown in figure. We are supposed to find Vs using mesh analysis. Let us see the figure. According to mesh analysis, step 1 is to identify the number of nodes. Step 1 is to identify the number of meshes. Number of meshes, let it be 1, let it be 2, this is 3 and this is 4. Number of meshes equal to 4. Step 2. Assign mesh currents in each and every mesh. I1, I2, I am assuming in clockwise direction. I3 and I4 I am assuming in anti-clockwise direction. Reason why is here it has been clearly given in the circuit 50 volts and related traveling of current. Current always flows from higher potential to lower potential. So I am assuming I4 to be traveling in this direction. I1, I2, I3 and I4 are the assigned mesh currents. Step 3 is to write KVL equation to each and every mesh. Applying KVL to mesh 1. Let us start with 60 volts and then we'll write voltage drop across 3 ohms, then 1 ohm. Minus 60 plus 3I1 plus 1 into I1 minus I2 equal to 0. By rewriting this equation, 4I1 minus I2 equal to 60. Let this be equation number 1. Applying KVL to mesh 2. We'll start with writing 1 ohm resistor voltage drop, then 5 ohm, then 2 ohm. 1 into I2 minus I1 plus 5 into I2 plus I4. If you observe here, I2 current and I4 currents are flowing in the same direction. So we'll write 5 into I2 plus I4 plus 2 into I2 minus I3 equal to 0. By rewriting this equation, minus I1 plus 8I2 minus 2I3 plus 5I4 equal to 0. Let it be equation number 2. Applying KVL to mesh 3. I'll start with 50 volts, then voltage drop across 4 ohm, then voltage drop across 2 ohm. Minus 50 plus 4 into I3 plus 2 into I3 minus I2 equal to 0. This equation can be rewritten as minus 2I2 plus 6I3 equal to 50. Let this be equation number 3. Applying KVL to mesh 4. This is mesh 4. I'll start writing voltage drop across 5 ohm, next 10 ohm and then Vs. 5 ohm 5 into I4 plus I2 plus I would like to write here voltage drop across 10 ohm 10 into I4, 10 into I4 minus Vs equal to 0. This equation can be rewritten as 5I2 plus 15I4 equal to Vs. Let this be equation number 4. Here we are supposed to solve 4 equations to find the mesh currents I1, I2, I3 and I4. For this we take the help of given data. It has been given that there is a voltage drop 50 volts across this 10 ohm resistor. So I can write here current flowing in this resistor I equal to V divided by R. V equal to 50 volt by R is 10 ohm, which is equal to 5 amp. I is nothing but here I4, right? I'll take I4 equal to 5 amperes now. I like that statement here. Given voltage across 10 ohm resistor is 50 volt. So current flowing in 10 ohm resistor is given by I equal to V divided by R. This I equal to I4, 50 divided by 10, that equal to 5 amp. I will substitute I4 equal to 5 amp in equation 2 because in equation 2 we have I4 variable. I'll substitute it. Substituting I4 equal to 5 amperes in equation 2, you can see equation 2 here. I will get minus I1 plus 8I2 minus 2I3 plus 5 into 5, 25 equal to 0. I will rewrite this equation as minus I1 plus 8I2 minus 2I3 equal to minus 25. Let this be equation number 5. Now solving equations 1, 3 and 5, we get the values of I1 as 15.23 amperes, I2 as 0.941 ampere and I3 as 8.65 amperes. This is step 4. Solving equations 1, 3 and 5. Mesh currents are obtained I1 and I2 and I3. According to question, we are supposed to find the value of Vs. Let us substitute all these values in equation 4. Substituting I2 and I4 in equation 4, we get 5 into 0.94 plus 15 into 5 equal to Vs. So Vs equal to 79.7 volts. This is the final answer of this circuit. That's all for this video. Thank you.